Next word problem says, what is the velocity of a ball that is dropped at rest, dropped from rest, uh, and falls a distance of 25 meters? And so here we're going to use conservation of energy. So let's write down the givens. We have really only one given, 25 meters, so that's a distance which I'll call x. And so let's draw what's happening. So ball is dropped, so that means that this is the ground. You're somewhere up here, maybe on a building, and the ball is dropped and it falls this distance. So the distance fallen is actually, it's a vertical distance, so I'm going to call that y. And so it starts off, the ball starts off up here at initial height y. It says at rest, or from rest, which means that the initial velocity is 0. And when the ball is just about to hit the ground, the final height y here is going to be 0. And we're trying to find the velocity right before it hits the ground, so we're trying to get the v final. So here, the basic concept is that the energy that you start with here, initial, is going to be the same, if nothing interferes with the ball, is going to be the same as the final energy down here. And here, the total initial energy is all, there's no motion, it's all because of height, so the total initial energy is all potential energy. And down here, it's underground, so the height is 0, and it's only, and it's all the energy comes from the fact that it's moving. So the final energy is going to be all kinetic energy. And if you combine those two equations together, you wind up getting this formula, that the final velocity is going to equal the square root of 2 times gravity multiplied by the initial height. So this is just a plug-in now. So the final velocity is going to be 2 times gravity multiplied by the initial height, which is 25. And that'll give you a final velocity of, you see your final speed of 22.1 meters per second. So here is the next word problem. It says, how long will it take for a 15 kilowatt motor to lift a 5,000 Newton car to a height of 20 meters? So go ahead and pause, try to solve this one, and when you're ready, unpause. So let's write down what's given. You have a 15 kilowatts. K is 1,000, so I'm going to convert this automatically. So this is 10 to the 3 watts. Watts is power. And 5,000 newtons, which is a force. And we have 20 m, which is a distance. So I'm just going to call it x. But let's draw what's happening. So this is the ground. You have a car. The force is actually the weight of the car, so this is Fg here. So the car has a weight Fg. And you want to apply a force to lift it at a constant rate. So the force that, in this case here, the motor is going to apply is going to be equal to the weight. So this is also going to be, this is the force that the motor applies. And the motor is going to be able to lift that car to a height of 20. So instead of x, this should actually be y for height. So the motor raises the car over this height of 20 meters, and depending on the power of the motor, it's going to do it either fast or slowly. So it's going to take some time t for the motor to raise the car to that distance. And I'm trying to find the power of the motor. So in this case here, the power of the motor is going to be equal to the work that the motor does, or the force that the motor applies multiplied by the distance that the force applies, that the force is applied, so y, and divided by the time. And specifically here, if the car is raised at a constant velocity, the force that the motor applies is going to be the same as the weight of the car. So the power in this case is going to be the weight of the car multiplied by the height that the car is raised divided by the time that it takes to raise a car. And so we can plug in here. The power is 15 kilowatts, so 10 to the 3 and the weight of the car is 5,000. The height that the car is raised is 20, and divided by the time. So the time is going to be 5,000 times 20 over 15,000. And that will give you 6.7 seconds.